This lesson will be the summary or the review for the chapter on circles. So my objective is I can solve problems involving circles. What I'd like you to do is start off with just this first one here. This problem where it says measure of an arc versus the length of an arc. What I'd like you to do is I'd like you to go ahead and find out, if you can, the length of this arc here. If this is a 50-degree angle and that's 3 inches, what's the length of that arc? So pause the video and try to solve that problem. Now that you've tried it, let's do it together. Just a reminder, because this is review, here's some of the terms and the different information we have. The measure of an arc, and this is in degrees, not in arc length, not the length of it, but just the measure, that equals the measure of the central angle. So this angle here is 50 degrees. That arc is also 50 degrees as part of what we are reviewing. Now, length of an arc, so that's a difference there. That's actually finding how long it is. What you want to do is you want to find the fraction of the circle that we have with that arc. And remember, that's taking the measure of the arc in degrees and dividing it by 360, because 360 is a full circle, and then multiplying by the circumference of the circle, because that gives the portion of the entire circumference with that fraction that we're doing. So in this case, what it would look like is whatever the measure of the arc is, we'll call that x over 360, divided by 360, and you multiply it by 2 pi times the radius, because the radius, that gives us the circumference if we multiply the radius by 2 pi. Okay, let's do the arc length here. So the arc length for this one, what we want to do is we want to take the 50 and divide by 360, because that's the angle, is also the arc measure. Multiply that by 2 pi times the radius, which is 3. When we simplify that, we get, when we multiply that all out, treat this like it's over 1 and multiply the top together and the bottom, and we get on this 300 pi, multiply the top together, over 360 times 1, which simplifies, if we were to simplify that down, we would get 5 pi over 6. And in this case, it's in inches, and we're dealing with the length of something, so it's just our inches. All right, now here's something that is new, but we can talk about it in terms of what we know. A full circle is 360 degrees. If we've got this quadrilateral that has been circumscribed by the circle, remember that this angle, if it's on the circle, the arc length here, if you take that arc length, take half of it, you get that angle. If you take half of this arc length, you get that angle. Well, what we can do is we can use that to say this is half of 160 up here, so that's from here to here. Notice then that the rest of this would be 200. When we subtract it from 360, so we get 200 degrees for this arc length. And so x would be half of that. X equals 100 degrees in this case. Now, here's a shortcut. That's the way we reason it through with what we know. It ends up being, if you have this quadrilateral that's inscribed inside the circle, so the circle's circumscribed around it, the opposite angles are supplementary. So opposite angles are supplementary when we have this situation. That will speed up us doing these problems when we've got this circumscribed quadrilateral. So all you have to do to get x is take x equals 180 minus that 80 that we know to get the 100. reason through what the arc lengths are. So that's another type way of we can apply using what we know about those arcs and angles. Let's go ahead and summarize now with our formulas. So here's the formulas for when we're dealing with the angle being on the circle. These are the diagrams of the types of ones that we have. So if I call this angle X and this arc A, this is a little bit different notation just to try it in a different way. I'm going to say that X is just half of the arc, A standing for arc. So on this one, if this angle is X and this arc is A, it applies also. I get the angle half of the arc if the vertex of the angle is on the circle. Now, if the vertex of the angle is inside the circle, what we have to do is if I call this angle X here, and I'll call this arc A, and this arc B. So when I do that, that angle is half the sum of those two arcs. So X is going to equal 1/2 adding the two arcs together to get that sum. Okay, now another smaller type of problem is, what if it's a central angle? Well, we just talked about this. If it's a central angle, this is X, and we'll call this A. X in this case is just equal to A. Okay, it's just equal to the arc. That's because if I were to draw this out here, this arc over here would be A as well. So it's half the sum of A plus A is 2A, half of that is just A. So we define the central angle and the arc measure as being the same. All right, let's finalize this by talking about what happens when we're outside the circle. Let's try that again. Okay, outside the circle, notice these are diagrams of different ones that we could have. If I call this angle X, and I call the far arc here A, and the smaller arc here B, it's important to know which one's bigger and which one's smaller. So in this one would be X is here for that angle, the larger arc is A, smaller arc is B. And do the same thing here, X is the angle, make the larger arc A, smaller arc B for this, in this case it's tangent and tangent. In this case, our formula is that X is going to equal half of the difference of the arcs, the larger one minus the smaller. I'm going to emphasize that you need to list the larger arc first to subtract. And you can use that to solve it when the vertex is outside the circle. So here we have several formulas that relate arcs and angles. We can use those to solve problems in our circles.